Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll recap what we learned in week 3. So we learned two things, completing the square and graphing any parabola. So let's start by looking at completing the square. So let's say we have this quadratic equation here, x squared plus 4x plus 8 equals 0. So when we're completing the square, what we want to do is we want to write a perfect square. We want to write this as x plus some number squared plus or minus some number. So this can help us solve quadratic equations. It's also useful because if we wanted to graph this parabola y equals x squared plus 4x plus 8, this number's the x coordinate and this the y coordinate of the turning point. We'll also see later that this will be useful when we're trying to find things out about circles in the Cartesian plane. Okay, so how do we make this look like a perfect square? So remember, when I refer to A, I'm referring to the coefficient of x squared, B, the coefficient of x, and C, the constant term. What we put in this first box here is whatever B is divided by 2. So in our expression up here, B was 4. So in the brackets goes 4 divided by 2, which is 2. So why is it B over 2? Why did I pick that of all numbers? Well, if I expand x plus 2 squared using FOIL, I get x squared plus 4x plus 4. You see, when we expand something like this, the coefficient of x is double this coefficient here. So that's why B over 2 goes in the brackets here. If I put B over 2, in this case 2, when I expand it, what you can see is the first two terms here are the same as the first two terms in the original equation. But this term, the constant term, doesn't always match up. So you can see here it's different than in my original equation. And that's why we need to have this box here. You see, if I expand x plus 2 squared, I get x squared plus 4x plus 4, not x squared plus 4x plus 8. So what I can actually do is I can add 4 here to make this a perfect square. This in blue is x plus 2 all squared. But I can't just add 4 wherever I want because that would change the equation. So to balance out the adding 4, I need to subtract 4 as well. So what goes in this box is 8 minus 4, which is in this case positive 4. So this time it's a positive. So when we have an expression like this, this is in completing the square form. But this equation here couldn't be solved because I have a perfect square plus a perfect square. I can only solve it if it's the difference of two squares. But let's look if I'm an equation like this. Well, now I'm going to try and solve it using completing the square. So what would go in the brackets is x minus 3 squared. The reason it's minus 3 is because it's half of b, half of minus 6. But if I expand this, the last term would be minus 3 all squared, which is positive 9. So if I add the 9 here, this is a perfect square. These two things are equal. But again, I can't just add a 9. If I add it, I have to take it away so that the equation's still balanced. So what goes outside the brackets is 1 minus 9, which is minus 8. So this is another example of completing the square. Now I couldn't solve this one, but I can solve this one because this isn't the sum of two squares, it's one perfect square minus another perfect square. So the way we do difference of two squares, you square root the first thing, put it in each bracket, and you square root the second thing. So for 8, its square root, I'm just going to write like this. And then 1 gets a plus, 1 gets a minus. So the solutions to this equation, if the first bracket equals 0, I get 3 minus root 8. I just subtract this thing here. And if this bracket equals 0, I get 3 plus root 8. They are the two solutions. So you can solve it when we have a minus here, but you can't solve it when we have a plus there. All right, let's look at graphing any parabola now. So if I want to graph a parabola like this, I need to identify 4 features. The first is whether the parabola is a smiley face. That occurs if a is greater than 0, or if it's a frowny face, which is if a is negative. So in this equation here, a, that means the number in front of x squared. So a is 4, it's positive, so this parabola will be a smiley face. So secondly, I look at the y-intercept. So the y-intercept is just c, the constant. So remember, a the coefficient of x squared, b the coefficient of x, and c the constant term. Here, the constant term is minus 18, so the y-intercept is minus 18. Minus 18 is the y value when x equals 0. All right, thirdly, where the work starts to happen, you need to find the x-intercepts. So to do that, you need to let y equal 0. So you may have 0, 1, or 2 x-intercepts. And that corresponds to whether the resulting quadratic equation has 0, 1, or 2 solutions. So let's take this equation and let y equal 0. So because this is a non-monic trinomial, we could use the quadratic formula or the AC method of factorization. So I'll use the AC method. So here, AC is minus 72, 4 times negative 18. So the two numbers that multiply to minus 72 and add to 6 are 12 and minus 6. So what we do is we split up the middle term into 12x minus 6x, and then we factorize the first 2 terms separately to the last 2 terms. So factorizing the first 2 terms, the highest common factor is 4x, so I'm just left with x plus 3, and for the second 2 terms, the highest common factor is minus 6, and I'm left with x plus 3. When using the AC method, you should get one bracket that is the same, so then you move that bracket out the front, and then what's left, 4x minus 6, goes in the other brackets. So if 0 is equal to this, I can use the null factor law. Either the first bracket equals 0 or the second bracket equals 0. If 4x minus 6 equals 0, then x equals 1.5. So the final thing you need to find is the turning point and axis of symmetry. You can do it in one go. So the turning point, the x-coordinate of the turning point, you use the formula x equals minus b over 2a. So in this case, b is 6, so it's minus 6 over 2 times a, which was 4. Or in other words, it's minus 0.75. So that's the x-coordinate of the turning point and also the axis of symmetry. So to find the y-coordinate of the turning point, you need to substitute this value into the original equation. So putting that in the calculator, we get minus 20.25. So the turning point is minus 0.75 minus 20.25. So now we're going to plot all of this on the graph here. We can't really plot the orientation, but we can plot the y-intercept. So the turning point of minus 0.75 minus 20.25 is about there. And then we have the x-intercepts of 1.5 is about there, and minus 3 is there. Because it's a smiley face, we know it's going to come down through this intercept, keep going until it hits its turning point, stop and turn around, go through the y-intercept, and then up there. And we're done. That's all there is to it. All right, thank you so much for tuning into this video. Keep your head up. You're doing well. This has been the luckiest maths teacher in the world. Have a great day.